Hi everyone, welcome to lecture on strength of materials. Myself M. Dinesh Kumar, Assistant Professor, Department of Civil Engineering, Hindustan College of Engineering Technology, Coimbatore. Today we are going to discuss about shear force and bending moment diagram based on one problem. We have a cantilever beam of having 3-point load at a different distances. Okay. So cantilever means one end of the beam is fixed and another end of the beam is free. So this beam is called as a cantilever beam. So kind of load is point load. Okay. So first of all, we have to calculate the shear force and bending moment values. Okay. So first of all, what is meant by shear force? So shear force means algebraic sum of all the vertical forces at the section, right side and left side of the section is called shear force. And bending moment means algebraic sum of all the moments at the right side and left side of the one particular section is called bending moment. So the variation of shear force and bending moment is called shear force diagram and as well as the bending moment diagram. First of all, we have to calculate the shear force at particular points. We have A, B, C and D points. So you have to calculate the shear force at point B, shear force at point C, shear force at point B and shear force at point E. So shear force at point D. So for the shear force calculation, you have to draw the section between C and D. So you can consider left hand side or right hand side of your section. Now you consider the right hand portion of my section. In the right hand side portion of the section, we have a point D and we have a 800 Newton vertically downward force. We already know the shear force is equal to algebraic sum of all the vertical forces. Based on the sign conversion, right hand side of your section will be a positive, left hand side of your section will be a negative. So in case right hand side, if your point load is vertically downward means it will be positive, left hand side vertically upward means it's a positive. So based on our section, left hand side or right hand side portion of my section, 800 to 800 Newton is a vertically downward, so hence it is a positive one. So plus 800 Newton. So this is the value of shear force at point D. Then second one, shear force at point C. So in order to calculate the shear force at point C, you have to consider one section between B and C. Okay. So I consider initially I consider right hand side portion of my section. And the same way for the next section, I can consider only at the right hand side of my section. So on the right hand side of my section, all the vertical forces are vertically downward. So vertically downward means positive. So shear force means algebraic sum of all the forces. We have two forces on the right hand side of my section. So first force is 800 Newton, is vertically downward, that is positive. Then second force is also vertically downward, plus 500. So 800 plus 500, the value is plus 1300 Newton. The same way, you have to calculate the value of shear force at point B. Will be, you have to draw the section between A and B. You have to draw the section. So, previously we considered a right hand portion of my section. Similarly, for third section also you have to consider right hand side of your section. So, in the right hand side of your section, for the third section, we have a 3 vertically downward force. So, as per our assumption, vertically downward force in the right hand side will be positive one. So, first load will be 800 Newton plus 500 Newton also a vertically downward force. So, plus 500. Then next 300 Newton also vertically downward plus 300. The value is 1300 plus 300. The value is 1600 Newton. Similarly, there is no force between A and B. You have to calculate your shear force at A, right? So there is no force between A and B. So sum of all the vertical forces at the particular point. So the same value will be 1600 Newton. So we have to check the shear force at point A, sum of all the vertical forces. So all the vertical forces are vertically downward. So plus 800, plus 500, plus 300. The value also say 1600 Newton. So this true value indicates there is a no change, shear force change between A and B. So says that there is a no force acting between A and B. Okay. So we have 1, 2, 3, 4 shear forces value, 4 points, 4 shear forces value. So we have to draw the shear force diagram. Okay. So draw a baseline. So this is my baseline. Above the baseline, it will be positive. Below the baseline is the negative one. So for shear force at point D, shear force at point D is 800 Newton. So 800 Newton is positive. So above the baseline. So this will be 800 Newton shear force at point D. Okay. So the next one, there is a no forces between C and D. Hence it will be a straight line. If there is a no forces acting between the point means you have to draw a straight line. The next shear force at point C, the value is 1300 Newton. So 800 plus 500, the value is 1300 Newton. So at this point, the value is 1300 Newton. So there is no force acting between B and C. So it will be a straight line. Okay. Then next, the shear force at point B. The shear force at point B is 1300 Newton. At this point we have 1300. So plus 300, the value is 1300 plus 300, the value is 1600 Newton. There is a no forces acting between A and B. So draw a straight line. So join this line. So this will be a shear force diagram for a cantilever beam carrying a point loads. So all the forces are positive forces. So mention this will be a positive one. We already know the shape of shear force diagram. Whether your load is a point load, the shape of your shear force diagram will be a rectangle. So it shows that it will be a rectangle portion between the 2 points. So next one, bending moment calculation. For the bending moment calculation, the right hand side of your section, if your load is anti-clockwise movement means positive. If your movement is clockwise movement means it's a negative one. If you are considering a left hand side of your section, clockwise movement is a positive, anti-clockwise movement is a negative one. Okay, so first step, you have to calculate the value of bending moment at each point. So for that, you have to consider a section between the 2 points. So first, we want to draw a section between the points. So first, draw a section between C and D. If you are considering a section C and D means, so 800 Newton is a vertically downward force at a point D, and C is the point. So the distance between C and D is 0.8 meter as per your question. I am going to consider a section XAX between C and D. So the distance for the force 800 Newton at the section is X. We already know how to calculate value of moment. So moment is equal to force into perpendicular distance. So 800 Newton is a force. The perpendicular distance means, so the distance is X. So at a section, moment at a section X equal to minus 800 into 6. So because this force is vertically downward, it creating a clockwise movement, right? So clockwise movement means is a negative. At the right hand side, the clockwise movement is a negative, anti-clockwise movement is a positive. So hence the symbol is minus force into perpendicular distance. The force value is equal to 800 into perpendicular distance from the section is X. Okay. So if you are considering at x is equal to 0, okay, at x is equal to 0 means we have the value of bending moment at D. So, okay, substitute x is equal to 0 means 800 into 0, the value is 0. We already know at simply supported end and cantilever free end we have 0 moment. Okay, so it's 0 kilonewton meter. The next one, bending, next consideration, you have to consider the section between B and C. So this is my diagram. So B, C and D. I am going to consider a section between B and C at a distance of x from the last point D. Okay. So the distance is x. So the distance between C and D is 0.8 meter. Distance between B and C is 0.7 meter. We have to calculate the value of bending moment. What is bending moment? Force into perpendicular distance. First, you have to take at a point at a section. Okay. At a point at a section, we have 800 Newton at a distance of x. This 800 Newton is creating a clockwise movement. So I am going to consider as a right hand portion. So right hand portion means clockwise movement is a -1. So the force is equal to 800. This 800 Newton is acting at a distance of x from point D. So 800 into x minus the next force is 500 Newton. It's also a vertically downward force. The vertically downward force creating a clockwise movement. So clockwise movement means minus 500. What is the distance of 500 Newton from the section? The total distance is x. So x minus 0.8 means, so this is my total distance of 500 Newton from the section. At x is equal to 1.5 meter from the end, right? So 0.8 plus 0.7, the total value is 1.5 meter. If you are substituting s is equal to 1.5 meter means you can get the value of bending moment at D, right? So bending moment at B, so value is equal to, if x is equal to 1.5 meter means minus 800 into 1.5 minus 500 into 1.5 minus 0.8, the value is minus 1550 Newton meter. In similar way, previously we are considering x is equal to 0 if between section between C and D, right? So if x is equal to 0 means the bending moment at the free end will be 0. If you are substituting x is equal to 0.8 meter because the C point is 0.8 meter from the free end D, right? So we are considering x section between C and D. If you are substituting x is equal to 0.8 meter in this formula, that is minus 800 into 0.8, the value is minus 640 Newton meter. Okay, so you are calculating the bending moment at point D and point C and point D. The next one, you have to calculate the value of bending moment at point A. So if you want to calculate the value of point A means, bending moment at point A means, you have to consider one section between A and B, right? So I am going to consider a section between A and B. So at a distance of x from the free end capital D. So this is point B and this is point B and this is point B and this is point A, right? So the distance between C and D is equal to 0.8 meter. Distance between B and C is equal to 0.7 meter. The distance between A and B is equal to 0.5 meter. I am going to consider a section XCX between A and B at a distance of x from the free end D. Okay. So similarly, we have to calculate the bending moment. What is bending moment? What is moment? The force into perpendicular distance at a point of section. We have a 3 vertically downward force. The first force is 800 Newton. It is creating a clockwise movement. Clockwise movement is negative, that is minus 800. What is the distance of 800 Newton from the section is x. Minus 800 into x. The next force is equal to 500 Newton. It's also vertically downward force. It's also creating a clockwise movement. So clockwise movement is negative. So minus 500. The distance of 500 Newton is x minus this portion, minus x minus 0.8. The next portion, next load is 300 Newton. This 300 Newton also vertically downward force. It's also creating a clockwise movement. So clockwise movement means negative minus 300. The distance of 300 Newton is x minus 0.7 plus 0.8, the total value is 1.5. So x minus 1.5. So if you are substituting x is equal to 2 meter means we can get the value of bending moment at A. Because 0.8 plus 0.7 plus 0.5. The total distance is 2 meter. So if you are substituting x is equal to 2 meter means you can get the value of bending moment at point A. Substituting x is equal to 2 means you can get the value of bending moment at A as minus 2350 Newton meter. Okay, so this is the value of bending moment at individual points. The next you have to draw the bending moment diagram. Okay, so same you have to draw the baseline. Okay, so this is my baseline. Above the baseline it will be a positive, below the baseline it will be a negative. So this is point D and this is point C and this is point B and this is point E. So bending moment at D, right? Bending moment at D, the value is 0. So this value will be 0. The next one, bending moment at C, the value is equal to minus 640 Newton meter, equal to negative. So below the baseline, you have to draw the shear force below the baseline. So this value is equal to 640 Newton meter. The next bending moment at point B. So the bending moment at point B is minus 1550 Newton meter. So it's a negative 1. So below the baseline, 1550 Newton meter. The next last one, bending moment at point A is at x is equal to 2 meter, bending moment at point A is equal to minus 2350. So it's below the baseline. So 2350 Newton meter. The shape of bending moment diagram, whether your point load is, so your load is a point load means the shape of your bending moment diagram is a rectangular. Okay, just join these points. Okay, so this is my bending moment diagram. So it will be a negative. So all the values are negative. Okay, so this is bending moment diagram and this is shear force diagram. So this is the way to draw the shear force and bending moment diagram for a cantilever beam carrying a point load.